Hello, good morning all. Myself Dr. Uttra Chandrawat from Government College Kota, and I welcome you all in this e-lecture on the topic polymers classifications. So in the past lecture we went through the basic structure of polymers, under which we learnt about the linear polymers, branched, networked, and cross-linked polymers, and we also learnt about the basic difference in the linear and the branched polymers. So today we will cover their classification basis. As you know that numerous different polymers have been produced, and a lot more will be produced in the future, because this branch of science, it opens many doors to various avenues. Polymers, due to their different chemical nature and structure, they possess different physical, mechanical and thermal properties. So polymers can be classified into various types on the following basis, that is, by their origin, by the backbone of the chain, by their structure, by the composition, by the mode of polymerization, by the molecular forces, and by their thermal response. So, in the continuation of this, we come across the classification based on origin. On the basis of their occurrence in nature, polymers have been classified into three types. First is natural polymers. These polymers are found in nature, in plants and animals. Examples are protein, cellulose, starch, resins and rubbers. They all are natural polymers. Now we come to the second, that is semi-synthetic polymers. ये क्या है? Derivatives of cellulose such as cellulose acetate, rayon and cellulose nitrate, etc. They are example of this type of class of polymers, that is semi-synthetic polymer. Next is synthetic polymer. A number of varieties of synthetic polymers have been produced, namely polyethylene, polystyrene, nylon 6 and polyethylene terephthalate, butadiene, rubber, etc. Next is the classification based on the backbone of the polymer chain. So, organic polymer. If a polymer chain it contains only carbon atoms in the backbone, then it is termed as organic polymer. Got it? So, majority of these synthetic polymers, they are organic nature, because they contain only carbon atoms in their backbone. Next is inorganic polymer. On the other hand, polymers which lack carbon atoms in their backbone are called inorganic polymer. So glass and silicon rubber, they are the example of glass. Now we come to the classification based on the structure of polymers. So this we have learnt in the past lecture, but this is again a classification basis. So linear polymers, as you know, that these polymers consist of long and straight chains, and examples are high density polythene, PVC, etc. These polymers are relatively soft, often rubbery in nature, and they undergo softening or melting on heating and dissolve in many solvents. This we have already read in the past lecture. Branched polymers, as this also you know, that these materials, they contain linear chains with branches, and they are low density polymers. Example is low density polythene. Now next is cross-linked polymer. No, these are produced, as you all already know, that they are produced from bifunctional and trifunctional monomers, and they contain strong covalent bonds between various linear polymer chains. Examples are vulcanized rubber, urea, formaldehyde resins, etc. And as you know that these polymers are hard and they do not melt, soften or dissolve in soil. Now the next classification, that is fourth classification, is based on the composition of polymers. So homopolymer, that this is the polymer which is formed by the polymerization of a single monomer. These polymers, they contain a single type of repeating unit. Now we come to the copolymer. If two different types of monomers, they are joined in a polymer, then it is called a copolymer, and the polymerization is then termed as copolymerization. So some of the commercial copolymers, they include ABS plastics, SBR, nitrile rubber, styrene acrylonitrile, styrene isoprene, styrene, and ethylene vinyl acetate. Now we go into the details about the copolymers. If a chemist is synthesizing a polymer utilizing two distinct starting monomers, there are several possible structures. What are these possible four basic structures are? First is random. If the two monomers, they are randomly ordered, then the copolymer is not surprisingly referred to as a random copolymer. Alternating in an alternating copolymer, each monomer is alternated with the other to form an BA pattern. So now next is block polymer. In block copolymers, more complex repeating structures are possible. For example, AAA, BBB, AAA, BB, and so on. Now next is graft. Graft copolymers, they are created by attaching chains of a second type of monomer on the backbone chain of a first monomer. Now we come to the next classification, that is the fifth one, based on the mode of polymerization. This we are going to study in details also in the coming lectures, but today we will cover its basis, that is the mode of the polymerization. So based on the method of polymerization, polymers, they are classified as addition and condensation. Now what are these addition polymers? The addition polymers, they are formed by the polymerization of monomers containing double or triple bonds. For instance, formation of polyethylene from ethylene and polypropylene from propylene. And these addition polymers, those addition polymers which are formed by the polymerization of a single type of monomer, they are known as homopolymer. For example, polythene. Whereas polymers made by the polymerization from two different kind of monomers, they are known as heterocopolymers. Example, SBR, NBR. Now we come to the condensation polymers. These polymers are formed by the condensation of two different monomers which are either bifunctional or trifunctional. So in the formation of these polymers, small molecules such as water, alcohol, ammonia, etc. are eliminated. Examples are PT, nylon 6, nylon, etc. Similarly, monomers with three functional groups undergo condensation, resulting in the formation of what is known as cross-linked polymers. So this is all about the condensation polymers. And now we come to the next classification, which is based on the molecular forces. Intramolecular forces are the forces, as you know, that hold atoms together within a molecule. So in polymers, strong covalent bond join atoms to each other in individual polymer molecule. Intermolecular forces, that is between the molecules, they attract the polymer molecule towards each other. So it is to be noted here that the properties exhibited by solid materials like polymers, they depend largely on the strength of the forces between these molecules. So using this, polymers can be classified into four types, that is elastomers, thermoplastics, thermosettings, and now we come to the elastomers. Elastomers are rubber-like solid polymers that are elastic in nature. When we say elastic, we basically means that the polymer can be easily stretched by applying a little force. So the most common example of this can be seen in rubber bands, that is hair bands. Applying a little stress elongates the band. The polymer chains are held by the weakest intermolecular forces, hence permitting the polymers to be stretched. But as we notice, removing that stress also results in the rubber band taking up its original form. So this happens as we introduce crosslinks between the polymer chains, which help it in retracting to its original position and taking its original form. So our car tires, they are made up of vulcanized rubber. This is when we introduce sulfur to cross bond the polymer chain. Now, what are thermoplastic polymers? These are long chain polymers in which intermolecular forces, that is van der Waals forces, they hold the polymer chains together. These polymers, when heated, are softened, thick fluid-like, and hardened when they are allowed to cool down, forming a hard mass. They do not contain any cross bond and can easily be shaped by heating and using molds. And a common example for this type is polystyrene or PVC, which is used in making pipe. Now we come to the thermosetting. Thermosetting plastics, they are the polymers which are semi-fluid in nature with low molecular masses. So when heated, they start cross-linking between the polymer chains, hence becoming hard and infusible. They form a three-dimensional structure on the application of heat. So this reaction is irreversible in nature, and the most common example of a thermosetting polymer is that of bakelite. It is used in making electrical insulation. Now the fourth kind is fibers. So in the classification of polymers, these are a class of polymers which are thread-like in nature and can easily be woven. They have strong intermolecular forces between the chains, giving them less elasticity and high tensile strength. So the intermolecular forces may be hydrogen bonds or dipole-dipole interaction. These fibers, they have sharp and high melting points, and a common example is that of nylon 66, which is used in carpets and apparels. Now we come across the seventh classification, which is based on the thermal response. So this is mostly a revision of the previous classification. So on the basis of the thermal response, polymers can be classified into two types, thermoplastics and thermo. So what are thermoplastic polymers? These are the polymers which soften or melt repeatedly on application of heat without any significant change in their properties. And such polymers are olefinic polymers, nylon, PVC, etc. Now we go to the thermosetting polymers. Certain polymers undergo some chemical changes on heating and become an infusible mass. So the chemical changes that occurs on heating leads to cross-linking of the polymer chains and produces giant molecules. For example, phenol, formaldehyde, melamine, formaldehyde, epoxy resins, etc.